So following on from the previous video, the second fundamental theorem of calculus allows us to have a new way of expressing a function in this form here. And then we were looking at this example here. So I'm trying to express a graph. But I've given it to you in this form here. I've given it, so I'm trying to express this graph. But in effect, all that I've given, whenever I give you a graph in this form here, really, in effect, all that I've given you is the derivative to play with. All that I've given you is that the derivative must look like this. So me expressing a graph in this form here is just like me telling you that, oh, the derivative must be this. You somehow have to create this graph here. So this new way of expressing a graph is really me telling you that the derivative must be this, and then you have to somehow from here create the original function. Okay, so this whole thing here is a bit like me giving you this. I'm trying to express a new function here, but I've given it to you in this form here. So really, when I give it to you in this form here, all that I've given you is that the derivative must be x squared. You have to somehow from here get to the original the original function. So you could ask yourself, well, from here, why not just find the antiderivative? Why not just find the antiderivative of x squared? Because when you have the antiderivative, if you differentiate the antiderivative, it will give you this. So going back to this thing here, going back to this form here, why not just find the antiderivative of this, and then that will help us understand what the original function will look like. So when given this, if you get given a function in this form here, in effect, all that you've been given is that the derivative must be this. So all that you're given is that the derivative must be this. You have to slowly somehow work out the original function. But when you're here, you could ask yourself, why not just find the antiderivative of this, and then that would then help us understand what the original function would look like. But the problem is that it's not easy to find the antiderivative of this. Okay, so let's try and find the antiderivative of this. So you trying to find the antiderivative of this is like you trying to find out, you're trying to search for something that when you differentiate it, it will give you this. Okay, so let's try and find the antiderivative of e to the power of minus x squared. So we can imagine this as being a bubble here. So our first guess would be e to the power of this bubble, but this bubble is really negative x squared. Okay, so this would be our guess. Remember, we are trying to find out the antiderivative of this. So we are looking for something that in such a way that when you differentiate it, it will give you this. So our initial guess would be this. So let's try and differentiate this. When you differentiate this, it will give you e to the power of the bubble, which is minus x squared here. And then we've got to times with the derivative of the bubble itself. Well, the derivative of the bubble itself will be negative 2x. So when you make this to be your initial guess, if you differentiate this, it will give you negative 2x e to the power of minus x squared. You see, you see, when you differentiate this, it doesn't give you this. It just doesn't give you this here. So it's not actually easy to find. You see, if you have something like this, if you have e to the power of let's say x plus 3, you see it's easy to find the antiderivative of this, because you've got this e. You would make this to be your guess here, where you would make this to be your guess. So when you differentiate it, it would be e to the power of x plus 3, and then you've got to times with the derivative of the bubble itself. The derivative of the bubble itself is just simply 1. So in this case here, it's nice and easy to find the antiderivative of this. But because you've got this x squared here, it really complicates things, because you've got this x squared here. If you try and make this your guess here, minus x squared here, if this is your guess, differentiate it, it will give you e to the power of the thing intact, and then you've got to times with the derivative of the bubble itself. The derivative of the bubble itself is minus 2x. You see, you've got this x thing in here. It really complicates things. So finding the antiderivative of this is not easy, because when you come to differentiate the bubble itself, it will give you it will give you this x here, and it really complicates things. So finding the antiderivative of this is not easy. That's why we've got no choice but to leave it in this form here. Okay, so I will continue in the next video.